So we're actually looking at an engine cylinder sleeve now. The cylinder sleeve surrounds the combustion space. And if we zoom in, we can see that we've actually got some air inlet ports. That's these ports here. So that allows the air into the combustion space. And we should also have some exhaust ports. Actually, it looks like the exhaust ports would be mounted on the top of the cylinder liner itself, or on the top of the combustion space. So there may be exhaust gas valves on the top here and air inlet ports at the bottom. Usually this type of design is reserved for larger diesel engines because it's more common that you have both the air and the exhaust gas valves on the top of the combustion space. Either way, air comes in through these ports here, exhaust gas looks like it's discharged out of the top. There is one other similar arrangement actually that we could have here where exhaust gas ports would be on the left and air inlet ports would be on the right. But anyway, let's focus on the jacket water system. The jacket water system is actually within this space here. You can see we've got a gap, runs all the way along the cylinder liner, and we're going to fill that up with jacket water, and we're going to remove heat from the cylinder liner. So we're going to take away heat from the combustion space. The jacket water itself may exit out through these holes here, and it will most likely come in through the base. You can actually see there's a hole here, and it looks like that hole connects onto the jacket water internal passages here. There may be more than one hole. You can see another one here, and another one there, and that ensures we get a lot of cooling water flow going into the cooling water passages within the cylinder sleeve. And then the cooling water will flow up, take away some of that heat, flow out of the top, and we will cool down our combustion space. Normally, whenever you're using a liquid or a gas to take away heat, it will flow from the bottom to the top. That's because the liquid or the gas heats up and it wants to travel upwards because when you heat it up, it has a lower density. So rather than trying to pump it down, imagine it's getting hotter and we're trying to pump it down, we actually go the opposite direction and we say, okay, we'll pump it in the bottom. As it heats up, it will naturally travel up anyway, and we'll use our pump just to help it along. If we went the opposite way round, then we'd actually get a drop in efficiency. The same can be said when you're using a liquid or gas that is going to be cooled down. You will have it entering at the top because as it cools down, its density will increase and it will naturally progress downwards, but you use the pump just to help it along. So there's no point fighting the natural laws of convection because they're always going to be present. So if it's a liquid or a gas that is going to become hotter as it takes away heat, then pump it in at the bottom and allow it out at the top. If it's a liquid or a gas that is going to become colder, then pump it in at the top and take it out of the bottom. And that logic is true for many heat exchangers and industrial machines. So now we know a little bit about the cooling water system and what it's used for. What are some of the important design considerations associated with a cooling water system? Well, the first one, and perhaps the most important, is that water can freeze. If water freezes in your engine, it's going to expand, and if that occurs, the parts within the engine are not going to be able to contain the water anymore, and you're going to crack some of the components in the engine. So let's imagine for a moment that we had cooling water in these passages. It freezes, the water expands, and we're going to have loads of cracks that appear on our cylinder liner. Now, cylinder liners are not necessarily cheap. You may crack the entire cylinder block of the engine itself, and that will render the engine almost totally inoperable and you won't be able to repair it. So in order to get around this problem, we dose cooling water with antifreeze. That means that the cooling water can be exposed to sub-zero temperatures and it will not freeze. So antifreeze is very important. Usually it's mixed in with the cooling water itself. The other thing that's mixed in with cooling water quite often is a corrosion inhibitor. The corrosion inhibitor essentially just stops all of these internal passages, so all the area inside here, from rusting. So hopefully that clarifies in your own mind what cooling water is and its function within the engine. Let's move on to our final system now, which is the electrical system, also referred to as the electronic system.